Alright, hello, assalamu alaikum everyone. Let's start with complex numbers. This is the last topic of A2 level 9079 is the course code. Okay, so complex numbers comprises of a real part and an imaginary part. This is a real part and this is an imaginary part. A and B both are real numbers. Equals to Z can be W, can be anything. Okay. Now, the thing is, what is iota? When we get something like under root minus 3, we write it as no real number or no real root. What we do is we split it. This can be written as under root minus 1 is iota. So this can be written as under root 3 iota. Okay, now let's find out different powers of iota. Minus 1 is iota. Squaring both the sides, this value is also important. Okay. Now this is one form of writing. This is a complex number, a plus b iota. You can write x plus iy, doesn't matter. Let's talk about addition and subtraction of complex numbers. So if we have 2 plus 3 iota plus 5 minus iota, real added with real, imaginary added with imaginary. Similarly for subtraction, real added with real subtracted from subtracted, and imaginary with imaginary. Let's do multiplication. Multiply both the brackets. 10 minus 2 iota. Iota square is minus 1. 13 iota plus 10 minus 3 minus 1. 13 plus 3 13 iota. You can rearrange and write it like this. Now what is conjugate of a complex number? So if z is 5 plus 2 iota, z star will be 5 minus 2 iota. This is the conjugate. The sign of the imaginary number changes. W star will become 1 plus 3 iota. If P is minus 3 minus 5 iota, so real will remain the same, only the imaginary sign will change. Okay. Division of complex numbers. So question is 2 plus iota divided by 1 plus 3 iota. How do we proceed? Multiply by the conjugate and divide by the conjugate. Multiply the numerator with the numerator. Multiply the denominators. We'll apply the identity of a plus b into a minus b. That will become 2 minus 6 iota plus iota minus 3 iota square divided by 1 square minus write it separately. Now, another concept is how to find square roots of a complex number. These questions are straight away asked directly in the exam paper. Now you know square root of a complex number will also be a complex number. Squaring both the sides, I square is minus 1. I rearrange the equation. I'll start comparing. Real is equals to the real part. Imaginary is equals to the imaginary part. I'm comparing real and imaginary. Meaning 3 is equals to a square minus b square. 4 is equals to 2ab. So a becomes 2 upon b. Plug it in. Take the LCM. Solve the equation. I'm not showing the working of solving quadratic equation because it's pretty simple. Remember, it's a disguise equation. Disguise means it's a hidden quadratic equation. So the answers will come out to be 1 and minus 4. And since b is a real number, so we will reject it.
Allow this.
B is equals to square root plus minus 1. So b is 1 and b is minus 1. Now what is a? A is 2 upon b. 2 upon 1, 2 upon minus 1. Therefore, the square roots becomes 2 plus iota minus 2 minus iota. Okay? Now, the next most important thing in complex numbers is understanding what is an Argand diagram. Okay, remember that complex numbers are vectors. Why they are vectors? Because they have a magnitude and a direction. We say Argand diagram is a diagrammatic representation of a complex number. This is the real axis and this is the imaginary axis. Now if I say plot z, which is equals to 2 plus 3 iota on an Argand diagram, it means the coordinates are 2, 3 because this is real, which is x, and this is imaginary, which is y. So 2, 1, 2, 1, 2, 3. So this is 2, 3 is this, and this is my z complex number. Now if I want to plot a complex number w, which is 5 minus iota. So 5 on the real, 3, 4, 5, and minus 1 is here. So this is going to be my w. Alright, now if they say, this is how you plot it on an Argand diagram. For example, p is a complex number which is P is a complex number which is minus 2 plus 4 iota. So minus 2 is here and 4 is here. So this is my complex number. Okay, this is how you plot it on the Argand diagram. Now, how to find magnitude? Magnitude of a complex number is called modulus. Now, how do you find out the modulus? A plus b iota is my complex number. So, magnitude will be a square plus b square. This is important, okay? This is the key, this is the symbol for magnitude, for modulus. So if z is, so if z is 2 plus 3 iota, modulus of z will be 2 square plus 3 square, the whole under root. 4 plus 9 is 13. If w is minus 5 minus iota, w modulus will be 25 plus 1, because squares of a negative number are all positive, 26. Now let's talk about the argument of a complex number. Argument is the angle complex number makes with the positive x-axis. Meaning, if this is your Argand diagram, if the complex number is in the first quadrant, this will be your argument. If the complex number is in the second quadrant, this will be your complex argument. Okay? If the complex number is in the negative side, this will be your argument. And if it is on the in the fourth on the other side, this will be your argument. Now how will you find these arguments? Let's talk about that. In the first quadrant, it's alpha, pi minus alpha, minus alpha, minus pi plus alpha. Okay? Now, how to find alpha? Z is equals to a plus b iota. Alpha will be tan inverse b upon a. Take only the numbers, no signs. So the step 1 is plot complex on Argand diagram, so you know which quadrant you are in. Step 2, find alpha. Step 3, apply relevant quadrants formula. Now let's do an example. Find argument of z, which is minus 2 plus 3 iota. Now if you know minus 2 is here and 3 is here, this is where the complex number is. So first thing is alpha, tan inverse 3 upon 2. That gives you 0.9827. This is in radians, okay? This is alpha. Now the second quadrant formula is pi minus alpha. Subtract this from pi. Let's do another example. Now plus 3 minus iota, 3 here and minus 1 here. This is where it lies. So first thing is tan inverse 1 upon 3. Then over here the angle is minus alpha. So just write a minus sign with it. Tan inverse 1 upon 3 gives you minus 0.3217 as your answer. Now different forms of complex number. This is the normal form that we write a plus b iota. There's another form which is called standard form, polar form, which is r cos theta plus I sin theta, where r is the modulus and theta is the argument. The exponential इसको harmonic भी बोलते हैं. Exponential form is r e I theta, where r is the modulus and theta is the argument. Okay. Okay, another thing is complex roots occur in conjugate pairs. Meaning if one answer for complex number is 2 plus iota, the other answer will be 2 minus iota. Now what are roots? So sometimes when you have a quadratic equation, for example, like x square plus x plus 1 equals to 0. So if you calculate b square minus 4ac for this one, it's negative, which means no real roots. So you cannot get a real answer for this, but you can get complex roots for it. How to find complex roots? Plug it in the quadratic formula. Minus b, a is 1, b is 1, c is also 1. This under root minus 3 can be written as under root 3 iota. Why do we say they occur in conjugate pairs? Because this is a plus with an imaginary sign and this is a minus with an imaginary sign. Complex roots occur in conjugate pairs. There can't be a single complex number. Thank you so much for watching this video. Let's move on to part 2, where I will be solving the past paper questions. For that, you'll have to watch the next video.